Say hi from Cherish Math, and this is the question. Find the arc length MN in cm for each of the following sectors MON with center O. Use pi 3.142. Notice that for each of the angles given here, for part A, B, C, D, all these are in radians. So the formula that I'm going to use up is S stands for the arc is equal R, the radius, multiplied with the theta that is measuring in radian. Now for the first question, which is the A, I'm going to use S equal the radius, which is given here as 12 centimeter, multiplied with the theta angle at 1.1 radian. And the answer that I'm getting here is going to be 13.2 cm. For the following questions, part B, C, and D, I'm going to use the same formula, which is highlighted here, and the similar workings to solve all of it. And I just have to list down accordingly. You may just need to pause the movie here in order to look carefully on each of this calculation. Question number 2. The diagram on the right shows a circle with center O. Given that the major arc length EF is 25 cm and the angle of EOF is equal 1.284 radian, find A, the radius in centimeter of the circle, B, the minor arc length EF in cm. Use pi equal 3.142. For the part A, the same thing that I'm going to use up is actually S equal R theta. S stands for the arc, R stands for the radius, and theta stands for the angle in radian. Since the given arc here for the EF, the larger one, is 25, I'm going to substitute here, and that is equal to the radius times the radian, which is the angle here. I'm going to use 2 pi. That consists of the complete circle minus this part that I'm highlighting here is 1.284. 1.284, and let me simplify the thing here. That is going to be R times the value in the bracket here is going to be 5 after using the calculator. Now, what is the value of the R? Is by using 25 divided by 5, and I'm getting 5 centimeter. For the solution of the part B, I am going to use the same formula that I have written here, and that is going to be the radius of 5 times the angle theta. In our case here, that would be 1.284. 1.284. The answer that I'm getting here is 6.42. That stands for the arc of the minor EF here. Question number 3. The diagram on the right shows semicircle OPQR with a radius of 5 cm. Given that the arc length QR is 5.7 cm, calculate A, the value of theta in radians, B, the arc length PQ in cm. Use pi equal 3.142. For the part A, we know that for pi radian is going to be 180 degrees. That is exactly half of the circle. So now, for the arc of this P to R is a semicircle, that is going to be by using the radius of 5 cm times pi, which is the radian for the semicircle. And the answer that I'm going to get is 5 pi. To find the value of this arc PQ, I will have to do by using PR, which is the semicircle arc, 5 pi minus this QR given here is 5.7. And the answer that I'm getting here is going to be 10.01. When it comes to solve the problem of this angle theta, the same formula that I have introduced here, S is equal R theta is going to use. And since S given here is for the arc of PQ that I got it as 10.01, I am going to write it down here, is equal, the radius is 5 and the theta, I will just have to use it up. And now, what is the value of theta here that I'm getting? Is in fact 2.002 radian. To solve for the part B, which is the arc length of the PQ, this is the answer that I have solved earlier. And I completely solved the problem here. Thanks for watching and please subscribe.